So let's look at two examples of when we might actually use the area of a sector. In this first example we're looking at here, it's talking about a center pivot irrigation system. And if you're familiar with these, you might see in a field out there where they have an irrigation system that would rotate along the land to obviously irrigate it for their crops. And that's what this is describing. And what I'm looking to find is, well, how much area does that cover? So this is pretty much a straightforward, we're going to plug into a formula. The formula for area of a sector was given as A is equal to 1/2 radius squared times theta. In this case, I know that the radius of my sector would be 321 meters squared, or the radius of my circle. I also know that this center pivot is rotating 15 degrees. So I'm going to multiply by 15 degrees, but remember that I have to change theta into radian measure if it's not already given. So I'm going to multiply by pi over 180. We can just put all of that into the calculator, and we find out that the area that this is going to cover is approximately 13,488 meters squared. So that's how much this center pivot irrigation system would cover. That's the amount of land it would cover. So let's look at one more example. So in this particular example, we're talking about land that is required for a solar power plant. So again, maybe you've seen one of these, maybe not. If you're driving down the road and you look out into the field, you would see a big field filled with solar panels. And this question is referencing that idea. It says that a 300 megawatt solar power plant would require approximately 950,000 square meters of land to collect the amount of sunlight needed for that power plant. If the land is circular, we need to figure out what the radius is. They're giving us the degree of the sector of the circle, so we're kind of working our area of a sector formula backwards, if you would. So if I know already, and I'm going to kind of draw a picture here just to show you what's happening, I know that I have some amount of land. The area has been given to me already, and I know that this degree in here is 35 degrees. So what I'm asked to find is, what is the radius of this sector? So if my formula is area is 1/2 radius squared over times theta, then I'm just going to kind of fill in the material that I already know. The area was given to me at 950,000. On the right hand side, I have 1/2 times the radius squared times theta, which is 35 degrees, but we're going to go ahead and convert it into radians here. So I'm going to multiply by pi over 180. And we want to, that's all of the information that we were given to start with. Since I want to solve for the radius squared here, I'm going to go ahead and multiply 1/2 times this whole thing in my calculator and see what I get to kind of simplify the right hand side just a little bit. So I have 0.5 times 35 times pi divided by 180. And I end up to 4 decimal places with 0.3054. So I'm going to say the right hand side is 0.3054 radius squared. The left hand side is still 950,000, excuse me. Now to solve for the radius, I'm going to divide by 0.3054, and then I'm going to take the square root, so we can do that in the calculator as well. So I'm going to say 950,000 divided by 0.3054, and then I'm going to take the square root of that answer that I have. So second square root of that thing above And we can see then, or let me write it down here, we can tell when we do this on the calculator that the radius of this circle would have to be 1,763.6 meters in order to have an area given by the 950,000 meters of land. And that's how you kind of work both of these two application problems using the formula given.